Hello. Welcome back. Today, you will learn declaring variables and assigning values.
So in this lesson, we're going to get back into the Visual Basic Programming language itself, and we're going to talk about variables and data types, declaring variables, converting or casting from one data type to another, and so on. So you probably, at some point in your life, you've seen a simple algebra problem like this. 5 plus 7 equals x. Now, without a lot of thought, you can obviously figure out what the answer is. How do you solve for x? What's the answer? Well, using that same thought process, take a look at this Visual Basic code. X equals 7, y equals x plus 3, console.writeLine y. So what would you expect to be displayed in the console window? Well, the value 10, right? Well, you just read Visual Basic on your own without my help. It's just common sense, right? Now, honestly, there's probably a little bit more to it than just that. But let's start with this and move on from there. First of all, in this context, x and y are called variables. And a variable is simply a bucket in the computer's memory that will hold or contain a value. You can put stuff into the bucket, you can read things out of the bucket, or rather out of the variable. You can put new stuff in the variable, new stuff in the bucket to cover up the old stuff. So in this case, these buckets are just holding numeric values, but you can create buckets that are just the right size to hold dates and times, or strings like long passages of text like hello world, or really big numbers, or numbers that are after the decimal point, and a lot more. So in the case of our little code snippet here, we would expect both x and y to hold numeric values. Now we know that, but we have to use the Visual Basic language to express this to the compiler in the .NET Framework runtime. So remember, the runtime is what does the hard work of managing the execution of our application, and part of its responsibilities is allocating memory in the computer for our data. So here we have two data items, and we have to tell the runtime to allocate some space in memory large enough, two buckets in memory large enough to hold these numeric values. So let's begin by creating a new application to learn a little bit more about variables. We're going to write a little code, then we'll break it down and explain what's going on, then we'll add a little bit more to it after that. But as we move forward in this lesson, the big takeaway is that a variable is simply a bucket, my terminology, a bucket in the computer's memory that you can put data into and retrieve data out of, as long as the application is running. So let's do this. We're going to create a new project. There's several different ways to do this. I'm going to just select a new project on the start page, which will open up the new project dialog. And what we want to do is call this variables and click OK. And so I'm going to begin typing in some code. What I want you to do is to follow along. So if you don't already have Visual Studio Express 2013 for Windows Desktop open, please open it up right now. And this is really important. Watching a screencast tutorial is different than watching a sitcom or a sci-fi movie. You need to be an active learner. The only way you're really going to learn how to code is to actually get your hands dirty writing the code yourself. So follow along with me and actually type in the code. It'll help build muscle memory. Pause, rewind the video, watch it a couple of times if you have to, but make sure that you follow along. It's the best way to learn. And then the second thing I want to say is that the same rules apply here that applied in that second or third video where we created the Hello World application originally. You have to type it in exactly. If you don't, you're going to experience some errors. You're going to see those little blue squiggly lines appear. So you'll try to run the application, it won't work. You'll be like, oh my goodness, what do I do? It's broken, I can't figure it out. Well, look at the error messages. Make sure, compare what I've done with what you've done, and make sure every single character is right. Several times, almost daily, somebody says, Bob, I did exactly what you did. I watched your video and I did it myself and it doesn't work. What do I do now? And I don't know of a nice way to say this, but if it worked for me, I didn't edit this magically or whatever, and it didn't work for you, then you did something wrong. So double, triple check if you have to. Make sure you got it exactly the way that I have it if you want to get the same results that I have on screen, okay? But if you get stuck, let me know. I'll try to help you out, okay? So, all right, here we go. We're going to type in the following code. Make sure you're in between, your mouse cursor or your text cursor is in between the sub main and the end sub. And I'm going to stop talking and start typing. Okay, so let's talk about what this code is doing. The first two lines of code here in lines number 5 and 6 are where we declare our variable. So to borrow from the explanation earlier in this lesson, we're asking the .NET Runtime to allocate a space in the computer's memory sufficiently large enough to store numeric values. We'll have a value called X and a value called Y. So we're asking it to create two buckets that will hold these numeric values that we're going to eventually drop into them. So after we've created these buckets, or rather we have dimensioned these variables, we can begin to assign values into those variables. And most importantly, you can see that I've described the type of data I expect to put into those variables, X and Y. I'm using the word integer. So first of all, dim is a shortened term for dimension. You dimension a variable. In other words, you provide the dimensions or the size and the width, okay, of the new variable, and you're telling that to the .NET Framework, so it knows how big of a space in memory to create for the data that you're going to put inside of it. And there are many terms to describe this process, including declaring your variables or to create a variable. I use all these terms synonymously, but Visual Basic uses the term dim to dimension a variable. So the next part, or the last part, is the as integer part. It's the data type. So part of dimensioning a variable is to tell the .NET Runtime how much room in memory to reserve for this new variable. So in this case, an integer is a mathematical term that refers to a pretty big number that has no fractions or decimal values. So it can contain numbers between negative 2,147,000,000 to a positive 2,147,000,000. So if you need a larger number than that, there are other data types that you can use, and it'll create a bigger bucket in the computer's memory to store those types of values. But this is where we tell the .NET Runtime what the size of the data we expect to use is. And integer, there are smaller ones, but this is usually a standard. I don't want to go into the reasons why, but it's a common data type to use, even if you're only going to use like 7 and 3 and not 2 billion, okay? So there are many different data types. There are simple data types, complex data types, and later on you're going to be creating your own custom data types as well. But because I don't want you to be overwhelmed at first here, let's just keep it simple for a moment. We're going to talk about just the integer data type, and then we'll talk about the string data type in a little while. Next up, after we've declared these variables in lines 5 and 6, and we've given them names that we want to call them by. So the first variable is X. That region in memory, that bucket in memory, I'm going to call that one X. This bucket in memory, I'm going to call that one Y. So now in code, whenever I want to refer to my variables, I'll just call them by name, X and Y. So next in lines number 8 and 9 is where I actually assign values to those variables. So I can access them by just calling their name. So X equals 7. I'm taking the number 7 and I'm assigning it in memory to the value X. And then I'm going to read that value back out. What is X? It's 7. I'm going to add 3 to it. I'm going to assign that into the variable Y. And then finally, I'm going to say, what is the value of Y again? It's 10. I'm going to print that to screen using console.writeLine. Okay. So the equal sign is the assignment operator in Visual Basic. So in English, that line of code, we're basically saying in line number 8, set the integer called X to the value 7. All right, pretty easy. So let's go ahead and see if this will actually work. and it does. We simply print the number 10 to screen. Okay. So let's click the Save All button on the toolbar to save our changes. And since we're going to make a number of small examples here, we need to comment out the work that we've just done. So I'm actually going to remove this space. I'm going to add a space here. I'm going to select all of this code, and I'm going to use this comment out button that we learned about in the previous lesson. Make some more space for myself here. And just as a side note, I want to leave this code here. I could completely delete it from this project, but I'm leaving it here for you to reference. If you wanted to download the code that's associated with this video from wherever you originally downloaded it from or where you're currently streaming it from, it'll be available. And so I usually leave this code for you, but often I take this approach as well whenever I'm writing code. I'll comment out some old code that I've been working on, and I want to keep it around for reference while I'm writing some new code to replace it. And then after I'm 100% sure that this code absolutely works, I can go back and I can delete the old code. So this is just one of the little habits that you develop over time when you make some mistakes and like, what was I? You're writing code, somebody comes to your cubicle, you start talking with them, and you're like, what did I just do? What did I delete? Oh no, I gotta start all over from scratch again, okay? So you develop these little habits over time, and it's a habit that I would encourage you to get into as well. Don't delete things right off the bat. Comment them out first, rewrite. Once you're convinced that it works, delete the old code, all right? Okay, so let's create another example, but this time, let's work with a different data type. So let's do this. Okay, so notice that we're using the as string this time as opposed to as integer. String is the key word for creating a bucket in the computer's memory that can hold textual information, alphanumeric characters. Also notice that I can name my variables anything I want to within certain limits. So as a convention, because most programmers do this, I use a lowercase m to begin, or a lowercase letter to begin the name of the variable. So my first name, okay? Followed by, so I use the lowercase m, capital F, capital N. So capitalize each additional word after that. So this is called camel casing, and you should get into practice of doing this as well because many developers name their variables this way. So for now, let's just use strings and integers, but there are probably, again, another dozen different data types that we'll want to know eventually and we'll use throughout this series. So now let's go ahead and run our application, and you can see it simply prints Bob in the console window. So at this point, our code example is just a glorified variation on the Hello World application that we wrote back in lesson number 3. The only difference is that we've introduced a variable to hold that literal string, in this case Bob, as opposed to the literal string directly that we passed to the console write line like we did in the Hello World example. All right. So one more thing that I want to point out, you can actually condense your code from this, and let me rewrite this a little bit more succinctly. All right, so here we're both declaring the variable and then initializing its value all in one line of code. All right, so experienced developers like to write less code. So they're always looking for a convenient way to reduce the number of keystrokes that they have to type and reduce the amount of code that they need to look at and understand. And so you should get into that practice as well. Now, using one of the techniques that we learned earlier, let's go ahead and comment out the code that we were just working with here. Comment that out. Now, starting in Visual Basic 2008, I could even shorten that further to what you see now. I guess I could have just done this. Like so. All right. So make sure whatever you end up with, it looks like this, all right? The idea is this. The Visual Basic compiler is smart enough to see that you're initializing the new variable to contain a literal string. So why not just let the computer figure that out, the compiler to figure that out? It's important to know that in this case, the variable myFirstName is of data type string. It's not an unknown data type. Once we declare myFirstName like we've done right here, from that point on, myFirstName can only contain strings. It can't contain numbers or dates or anything else. All right. Just be aware that this is an even shorter way that you can now write you can now declare variables by implying what the data type is by what you initialize the variable to contain, as long as you do it in one line of code. All right. So what happens if we were to do this? Let's just comment out everything after the dim first name. What happens in this particular case when we don't give it a data type like string, and we don't give it an initial value like equals Bob? So in this case, you will not get an error message. Instead, you just created a variable of type object, which is the most generic data type in Visual Basic. It can hold anything. However, this is a horrible idea because it gets around the comfortable restraint of using a strongly typed programming language. Well, you might think, what? I can store anything I want in there. However, I assure you that what seems to be freedom is actually a noose because it'll lead you to errors that are difficult to track down. Trust me, stick with defining your variables with actual data types or initializing their values at the outset like we just did a moment ago, and stay away from object for now as much as possible. All right, so let's go ahead and get rid of this because I don't want you to even try that. Okay, so I want to comment out these two lines of code now, and we'll continue on from there. All right, so let's do this. Dim x. Okay, so let's walk through this. We have dim x is integer equals 7, dim y is string equals Bob, and so we have a numeric value and a string, which can be alphanumeric, and then we're going to create a new variable called myFirstTry. It'll be of type string, and then we're going to initialize it to x ampersand y. So this ampersand character is a string concatenation character, meaning that it'll take two strings and put them next to each other. All right, and it will make a new string out of it. All right, so in this case, we would expect it would myFirstTry to contain 7 Bob, no spaces, all one word, I guess you could say. All right, so what we're doing here, though, is we're implicitly converting this data from integer into a string by, well, we're just implicitly doing it. We're not explicitly saying you should be a string now. We're saying that whenever we're using the number 7, but we're using this ampersand, which is a string concatenation character, and we've already declared myFirstTry a string, which will be the result of concatenating a string to an integer. The .NET Framework knows that, well, I guess I can take a 7 and I can make it an alphanumeric. I can make it into a string. I mean, I don't have to treat it like a numeric value that you can add and subtract and do those sorts of things with. So I guess I'll go ahead and implicitly convert it, and I won't raise any red flags. I won't complain. We'll just let it happen. So first of all, let's make sure this works. It does. So we see 7 Bob on the screen. So that is an implicit data conversion. There are certain data types that can be easily coerced or converted into another data type that's a little more forgiving and open, like a string is. Alphanumeric, it can handle just about anything. It can handle a date and time. It can handle entire paragraphs, numbers. Why? Because it's just a collection of individual alphanumeric characters, all kind of put together to look like a date or a number or a paragraph or whatever the case might be. However, some conversions are not possible, and we'll talk about that in just a moment. Now, what's really going on behind the scenes, I guess, is that we're taking x.toString, and after we have converted x to a string, we're concatenating y to it. And you might be like, wait a second, whoa, where did that .toString come from? Well, most data types, even simple data types like the integer in the .NET Framework, have methods defined that perform some basic tasks like type conversion like you see here. So as a result of declaring a variable to be an integer data type, we get a bunch of add-on features for free whether we need them or not. They're kind of like baked into our variables. We'll talk about that more later. But you got to admit that's pretty cool, right? That you can just say, here's my variable name, dot something, and have it perform some cool tasks. And we'll see a lot of examples of that throughout this series. So don't be surprised if we do a dot, to upper in this case. And now look at what happens. 7 capital B-O-B, all right? Ignore I did that. We'll come back to upper later. Okay. So we can rely on .NET to perform implicit conversions of the data. However, I recommend against this. You should never rely on implicit data conversions. I encourage you to always take control of your code and explicitly perform conversions. Otherwise, you're likely to introduce subtle, hard to find bugs in your applications. So what I would recommend that you do with this line of code is probably get rid of this and use something that's a little more Visual Basic friendly, CSTR, which is convert this number into a string and then append this other string to it. And let's make sure that still works. And it does. It's just more expressive using the Visual Basic language with this built-in method called CSTR, convert to string, okay? All right, so let's do this. I'm going to comment out this line of code. And I'm actually going to comment out this line of code. And below it, I'm going to do this. All right, so let's start debugging the application, and we get an invalid cast exception occurred. And it says conversion from string Bob to type double is not valid. All right, so what happened? Well, in this case, you can see that my second try should be of type integer. We know we're going to take the value of x, which is an integer, and we're going to use the plus symbol, which is the addition operator. So we want to add numbers together. We want to add 7 plus another number, but we don't have a number here. We have a variable which is of type string, and it can't easily be converted into a numeric value because it's set to Bob. So I could try something like cint. Cint would be kind of the equivalent of the CSTR. Convert this string into an integer, all right? However, even at that, if I try to run the application, I'm still going to get the error that conversion from string Bob to type integers is not valid, all right? But that's perfectly understandable. So on the plus side, we have taken control of trying to explicitly convert our data types. On the downside, this scenario will never work because Bob can never be converted into an integer value. But we can do something like this, where we take dim y as integer, and set that equal to 5. And then rerun our application, and it will work just fine. All right. So we saw the number 12. What if we were to go back to this example here and see if we could implicitly convert those two numbers together? They are of value 7, 5. Not 75 because it's not numeric. It's just 7 and 5, and they're concatenated together and put next to each other. Okay. All right. So I strongly recommend that you do not rely on implicit data conversion. Some people would even call it evil type conversion. All right. So instead, take control of the conversion and be purposeful in the code that you write. You'll experience fewer defects in the software you write if you do not depend on the .NET runtime to handle these types of situations for you. Instead, you should use those two built-in Visual Basic helper methods that we demonstrated in this lesson. CINT or CINT will convert a string into an integer, and we could actually achieve the same thing with a built-in .NET function called integer.parse. All right, but I would recommend that you use the Visual Basic CINT instead. All right, so I'm just going to go ahead and delete that. You might see it used. And then use CSTR like we used here in order to convert an integer or some numeric value into a string. So it performs the same action as that toString that I talked about a little bit earlier that's baked into the .NET framework. Okay, so the key idea in this lesson is how to declare, initialize, and then work with variables and data types. In the .NET framework, even simple data types like string and integer have some powerful helper methods that are kind of baked in or built in to convert one data type into another data type whenever you need that functionality. However, from a stylistic perspective, I recommend that you use the built-in Visual Basic helper methods like CSTR or CINT, and there are others like them, in order to perform these explicit data types. But hopefully you understand the need for data conversion, how sometimes data conversion can be performed for you implicitly, but why that's sometimes a bad idea to rely on that. All right, so you should attempt to never rely merely on implicit data conversions whenever you're working with different data types. Take matters into your own hands and convert them explicitly. Okay, so we talked about a lot in this lesson. If you've got all of that, you're doing great. We'll see you in the next lesson. Thank you.
Great. See you at the next lesson.